Okay, this is Ken from Maker's Box. We're going to put together the MOSFET shield for the Strife. So we've got our circuit board, we've got a diode, resistor, we've got our MOSFET, we've got our fuse, we've got some pico blade connectors, we've got our XT60 connector, we've got some sections of 18 AWG wire for the battery, and some heat shrink. Okay, so I always like to start with the resistors. In this case, there's just one of them. You'll notice I've got a silk screen on here that shows the actual circuit, how it works, where the motor's at, the kickback diode. So hopefully that'll give you a little bit of an education here, but we're using a 10K resistor here as a pull down to keep our digital signal low until we're ready for it. We don't want that to drift and accidentally start our motor. So this will pull the signal down to ground. I've fed it through. This is not going to be a how-to solder video, but in general, you want your soldering tip up to temperature, nice, bright, and clean. You're going to touch your tip to your pad and your lead, component lead. You're going to wait for about 2 seconds, and you're going to introduce just a little bit of solder. And if the temperatures are right, you'll see it wick right in. So there's some other videos that show that much better than I can on these kind of cameras. These are my Hecco flush cuts. So you want to cut them off just above the solder joint. If you want to cut too close, you might tear up your pads, but you don't get it close enough. Okay, so with that, let's take the next lowest seating component, which is your kickback diode. This provides a path for voltage, has an inductive load like a motor or a solenoid, de-energizes and collapses. It will cause a back current or voltage spike. In this case, we're just providing a little bit of a path for it to fly back. It has a polarity, so there's a silver band on here which shows the direction, and then the silk screen will always show a band. So you know, make sure you get that right, because if you don't and you go to energize it, it'll just push all the current through the diode and it will overheat quite quickly. So the leads on this are quite a bit thicker than the resistors, so you're going to need a little bit more heat than usual, but it'll flow quite nicely. The star of our show here is a MOSFET transistor, and it allows the current to flow through as long as the signal is provided to its gate. So it's very good at switching large currents, and it lets us do things like so in the case of our Nerf blasters, allowing us to route our battery current straight from the battery to the motors instead of having to go through all the various switches and interlocks. It's a typical Nerf Strife. So let's solder one lead in, and then I'm going to come back, and we want this to kind of sit flush. And because this is going to be sitting inside the blaster like this, so this needs to be as flat as possible. So it by using a MOSFET instead of a so the stock Strife switches are only rated for a couple of amps, and so when you start upgrading your batteries and motors, they're not capable of those kind of currents. And so we either need an upgraded switch or a MOSFET. In the case of the switch, those are kind of expensive, and they're actually usually rated for 21 amps. So your aftermarket motors will draw more than that. You can get me going for quite a while on why you should leave your fuses in. As you upgrade to your motors, you can upgrade the appropriate capacity fuse. If you don't have a fuse in your system, your motors become your fuses, and they're of course non-resettable when they burn up. If you get a jam or you loan your blaster out to somebody, then your blaster's done for the day and you got to rewire your motors. So that is not fun. So I recommend putting fuses in. Bypassing your fuses will only get you a couple percent improved performance. The MOSFET itself will offset that performance straight out of the gate, so you're already in the positive on that. So there's no reason not to keep the right capacity fuses in. So we need a way to connect our Rev Switch into the circuit here, and that is through a Pico blade connector. I do have some points here if you want to directly solder in. You can do that. I kind of like being able to connect and unconnect, and you'll see the leads are a little bit offset, so these go in a specific way, although it actually for Rev switch doesn't matter. It's just a switch, so there's no positive and negative. And these leads are actually fairly close together, so you got to be a little bit careful with your tip. I'm using a big old fat chisel tip, so you can see it's still possible. You just want to make sure you don't bridge across there. And then, so that's the connector. This is the housing, and we've got some pre-crimped leads here. The tools to actually install these crimps are pretty expensive, whereas just buying them pre-crimped is pretty cheap. You wouldn't expect a hobbyist to have the tool for this. It's about $350. You can see there's a little bit of a keyway sticking down, and then on top there's a little protrusion. I don't think you can see it in the video, but that sticks upwards, and then that's going to go into and lock in when that gets in place, and you'll feel it lock in. You can use an X-Acto blade to lift up that plastic tab if you need to get it off. Again, hopefully you don't. I'll put that other one in there. And so this is going to connect right into your switch, and then this will go down and attach to your, you'll solder this into your Rev switch. And then all that's left is to solder in your battery connection and your motor connection. Alright, so hopefully you'll see how easy that is. And I've left some white space on the silk here so you can write in what your fuse values are, because this is going to be facing upwards, so you'll be able to remember if you go to look at it later. Alright, thanks for watching.